if you ask, it is the product of the charge and distance between the oppositely charged centers, and it could be represented by the letter mu. Mu is equal to E into distance, charge into distance. And one important property of this dipole moment is it's not a scalar quantity, it is a vector quantity. And if you want to predict the dipole moment of a molecule, you have to take the vector sum of all the dipoles. Dipole moment, if you take HCl, it is negatively charged and H is positively charged. So there will be a bond dipole, the direction is towards electronegative atom, understanding? And this is what we call bond dipole. Bond dipole. And if you want to get dipole moment of a molecule, you need to take the vector sum of the bond dipoles. And if you are drawing for dichlorobenzene, Cl, it is easy. Benzene is a symmetric molecule, its dipole moment will be 0, and here the dipole moment will be directing away from each other, so that this will get cancelled. If you take next one, Cn, its hybridization, what is the hybridization of Cn? Hybridization of Cn, sp hybridization, so it's linear. The same happens, it will be added to the bond dipoles of benzene, that also will get cancelled. Then if you take OH, it will not come like that, because you know that water molecule, it is like this, 2 lone pairs of electron, right? Water molecule is having a positive dipole moment. The same way, if you take OH like this, here also like this. Even if it is this side, it will not get cancelled, right? It will not get cancelled. It will be getting added. So the dipole moment of this dihydric, the phenol, that phenolic group will not be 0. It will be greater than 1. Then what about SH? Same. It is H2S. If you draw, instead of oxygen, what is present in the next molecule? Sulfur is present. And the geometry is almost the same, and the dipole moment will not get cancelled. When it is not getting cancelled, what about the dipole moment? It will not be equal to 0. Then what is the answer? C and D. Have you understood? Remember, dipole moment is a vector quantity. To find out theoretically what is the dipole moment of a molecule, you need to take the vector sum of the bond dipoles. Bond dipole means the dipole moment of each bond. Okay. Again, it is a direct question. Cesium chloride is having what type of crystal lattice? Body centered, right? Body centered. Or the 8 cubes will be occupied by chlorine atom, and at the center position what will be there? Cesium will be there. And a cube, at the center cesium is there, all corners will be occupied by chlorine, and the length, the edge length is represented by the letter A, and there is a standard, you must have derived it, there is a standard equation, that is 2 into RCS plus 2 into R Cl minus is equal to root 3A. This is a standard equation, and if you divide the whole equation by 2, you will get what? Root 3A by 2. Easy one. So the answer is which one? B is the correct option. Okay. Which one is classified as a condensation polymer? There are 2 types of polymers. One is addition polymer. 2 molecules will be added without eliminating any atom or any molecule. Whereas condensation polymer, 2 different monomers will get added and some molecule will be condensed. condensation polymer. Here again it is not on the basis of logic, you need to know, you have to be familiar with this. Neoprene is formed out of isoprene, it is an additional polymer. Teflon, tetrafluoroethene, Teflon, that also an addition polymer, whereas acrylonitrile also formed as addition polymer, monomer is acrylonitrile, whereas dacron is terephthalic acid and ethylene glycol. So the structure is like this. CO2H, this is what terephthalic acid, and it is combined with CH2, CH2OH, ethylene glycol. Okay, and if these two combines and go for condensation, you will get a polymer like this. This is what dacron. Dacron polymer is this, and it is a condensation polymer. For the estimation of nitrogen, Gerald's method, it is on the estimation of nitrogen. Ultimately what you have to find out is, you have to find out the percentage of nitrogen. So percentage of nitrogen is given by the mass of nitrogen divided by mass of compound into 100, right? This is how we get. And the strategy what we use is, we take some sulfuric acid of a particular molarity, H2SO4, and it will be treated with NH3 to give NH4 twice SO4 plus H2O, right? And one more thing happens, you take some amount of H2SO4 and that will be treated with whatever be the available ammonia is there, which is produced out of nitrogen present in the organic compound, and the reaction happened, and the remaining amount of H2SO4 will be treated with here 2 NH3, here 2 NaOH, you will be getting Na2SO4 plus 2 H2O, right? I'm sorry, here H2O is not required. Fine. If you know this equation, you can easily answer. So let me ask you a question. Suppose the number of moles of NaOH required to treat the remaining H2SO4 is 2 mole. Suppose we will take it as 18 mole. 18 moles of NaOH is required. Then how many moles of H2SO4 will be there? What is the ratio? 1:2. Here 18 mole, here it is 9 mole. Okay. And initially you have taken 10 mole. Listen, easily you can work out. You have taken 18 moles of NaOH to treat with the remaining amount of H2SO4. So what is that amount of H2SO4? 9. And initially you have taken 10 moles of H2SO4. Then how many moles of NH3 will be there? How many moles of NH3 will be there? 10 minus 9. How many moles of H2SO4? 1 mole. And this 1 mole of H2SO4 react with how many moles of NH3? 2 mole. You understood the logic? So first you have to find out what amount of H2SO4 you have initially taken. So what is that? You have taken 60 ml of M/10 sulfuric acid. So 60 ml, M/10 means 0.1, right? So how many moles? 6 millimole, right? So how I have written millimole is 0.1 mole per liter. So liter and liter will get cancelled. 6.1, 6 millimole. Initially how many millimoles of H2SO4 you have taken? 6 millimole. Now we will find out how many moles of NaOH is required. Unreacted acid required 20 ml of M/10 sodium hydroxide. So 20 ml into 0.1 moles per liter NaOH. So how many moles of NaOH? How many moles of NaOH? 2 millimoles of NaOH. Tell me, to treat with H2SO4, how many, suppose if you are taking 2 millimoles of NaOH, how many millimoles of H2SO4 is required? 1 millimole of H2SO4. That you have to subtract from there. From where? 6. So remaining how many? 5 millimole. So if it is 5 millimole, how many millimoles of NH3 will be produced? How many millimoles of NH3 will be produced? 10 millimoles of NH3. Then can't you find out mass of nitrogen? 10 millimole of nitrogen into, what is the mass of nitrogen? 17 gram of ammonia contained. So NH3 molecular formula is this. So 17 gram of ammonia is equivalent to 14 gram of nitrogen, right? So you can write mass of nitrogen is how many mole? 10 into 10 raised to minus 3 mole of nitrogen into 14. Mass of compound is given. What is that? 1.4 into 100. How I solved this equation is, I know we should know that the reaction happens between the number of moles. So if you take H2SO4, it reacts with how many moles of NH3? 2 moles of NH3, and H2SO4 again reacts with how many moles of NaOH? If you keep that in your mind, and if you know to find out the number of moles by multiplying the volume and the molarity, you can easily find out the answer. Did you follow? Okay, so the answer is 10%. Next one. For complete combustion of ethanol, C2H5OH plus 3O2 gives 2CO2 plus 3H2O, right? And the amount of heat produced as measured in bomb calorimeter is 1364.47 kilojoules per mole at 25 degrees Celsius. Assuming the ideality, the enthalpy of combustion, this is delta CH, it is supposed to be here, for the reaction will be R is equal to 8.314 kilojoules per mole. And what is this? What do you measure by using bomb calorimeter? What do you measure? You can measure only internal energy. Internal energy. So by using bomb calorimeter, you can measure the internal energy. So delta E, and you have to find out what? Enthalpy of